In this video, we're going to go over some basic terminology involved with graph theory, and we're going to use the example over here from the Bridges of Königsberg. The first two things we talked about in the previous video, and that was vertices and edges. So the vertices in this case are the A, B, C, D. Right, these are the points that you are talking about in your graph. Then we have the edges. The edges connect two of the vertices. And so, for example, this edge right here, this connects vertex A to vertex B. So edges are what we use to connect vertices. Now it is possible to have a graph where you have an edge that starts at a vertex and goes back to the same vertex, and when you have that, that is called a loop, and this connects vertex A to vertex A. Now, whenever you have an edge, they're going to have two endpoints. So each edge has two endpoints exactly. You cannot have an edge that goes between three vertices. It has to go between two, and those two could be the same one. And then when we have the word connect here, is that two vertices are connected if there is an edge between them. Now I do want to point out something really kind of small right now, is that on this video we're talking about vertices being connected by an edge. However, later we're going to talk about whether a whole graph is connected, and that's a slightly different concept. So I just wanted to keep that in mind, that when you say vertices are connected, it means there's an edge between them. When you say a graph is connected as a whole, it means something slightly different. Now next up we have infinite versus finite graphs. Well, this one's fairly obvious in that an infinite graph has either an infinite number of vertices or edges, and a finite only has finite amount of them. And there are some important applications of graph theory that they need the infinite graph, but for the basic stuff that we're doing here, we're not really going to deal with them. So we're definitely going to focus on finite graphs here. Now, the next concept, this is actually going to be a particularly important concept for us, so I'll color it here, and that is the idea of a simple graph. And the reason why it's going to be important is that some things are going to be true about simple graphs and are going to work nicely, and if it's not a simple graph, they won't work as nicely. And so it's important to identify whether it's simple or not. And the short way of saying this is a simple graph is one that has no loops and no repeats. Now what do I mean by that is that each edge connects to two different vertices, and there are no two edges that connect the same. So in fact, both of these graphs that I have over here are not simple. The first one's not simple because you have two different edges that both connect A and B. You also have two that connect B and C, but any one time it fails, it's no longer simple. And the second graph here, where I have A, B, and C, has a loop, so that one's not allowed. So to give an example of a simple graph, I could just do A, B, and C, where they connect to each other, and then that's it. So that would be a simple graph. And as I said, there are going to be certain properties that are only going to apply to simple graphs. Now, a multigraph, this is just a graph that does have loops or repeats. So again, just if it's not simple, it's going to be a multigraph. These last three here, to talk about that, a directed graph, this is when edges can only be traveled in one direction. So you may have seen in some big cities they have one-way streets. So for example, let me just make up a little quick graph here. A, B, C, D. Maybe if you are currently in A, you can go to C, but it's a one-way street. You could not come back there. Similarly, maybe you can go from A to B, but not back. And maybe you can go from C to D, and you can go D up to B here, but you can't do any of the reverses. So that's what a directed graph would look like. Now, if you have a directed graph, it's possible that some of these you can go in either direction, and so what we can do is we can actually just draw a separate edge with the reverse arrow, and that would give us a edge that goes back the other way. So it's possible to have it, but the idea is if you are specifying only one direction, then it's going to be a directed graph. On the other hand, an undirected graph is when all edges can be traveled in either direction. Okay, and a mixed graph, this is going to be a graph with some directed edges and some undirected. And again, this is an important classification because sometimes the work we're going to do only applies to undirected graphs. Sometimes we only care about directed graphs. But we'll see as we go through examples which one is which and what we want to use for each category.